Hello, everyone, and welcome to our 30 Minutes to Faster Cloud Native Development webcast. I'm Bob Ewer from Oracle, and I'll be your host today. We'd like to welcome our special guests, Arnold Dyaratne from IDC and Matt Goldensohn from Gadget Software. We'll provide more on their backgrounds in a few minutes. With that, let's get started. So just a reminder as we start here of our safe harbor statement, this webcast is intended to really just outline our general product direction. Okay, with that, let's dig into our agenda today and provide a little bit more introduction to our speakers. Arnold Dyaratne is Research Vice President, Software Development at IDC. Dr. Dyaratne focuses on software developer demographics, trends in programming languages, and other application development tools, and the intersection of these development environments and the many emerging technologies that are enabling and driving digital transformation. Arnold's research examines how the changing nature of software development relates to broader trends in the technology landscape. At IDC, Arnold's coverage includes developer experiences, developer demographics, the changing nature of software development, as well as the intersection of software development with cloud computing, serverless computing, and PaaS environments, artificial intelligence, machine learning, IoT, and quantum computing. We're happy to have Arnold with us today. He'll dive into cloud native and DevOps definitions and what the adoption is looking like, as well as considerations for choosing a cloud vendor for cloud native and DevOps. We'd also like to welcome Matt Goldensohn. Matt is head of architecture at Gadget Software. He has 20 plus years of experience leading edge products and technologies and managing domestic and global R&D organizations, technical marketing, database, server, desktop, and operations and support engineering. He's also had 10 plus years experience as director, team lead, and manager, and an individual contributor for areas such as storage, server, and software companies in engineering, pre-sales, and technical evangelist roles. And finally, 10 plus years working in the financial services area, supporting trading and research applications. We're excited to have you both with us on the webcast today. So to start out, we'll turn the time over to Arnold, and he'll talk about tips and considerations for cloud native development, as well as some information on adoption. And after Arnold, we'll have a Q&A session with Matt around his experience with cloud native software and how it's going for Gadget Software. So with that, let me turn the presentation over to Arnold.
Thanks, Bob. So by way of an agenda, I'll be speaking about three things today. The first of which is the definition of cloud native development, followed by an elaboration of key benefits of cloud native development. And I'll conclude with some key considerations for selecting a cloud vendor that can support you on your cloud native development journey. Cloud native development is development that is optimized for distributed infrastructures and features the conjunction of four things: microservices, containers, and container orchestration frameworks, as shown on the left, and DevOps, which is shown on the right, which is defined as the automation of processes that facilitate collaboration between development and operations teams. There are two key features of cloud native development that I'd like to highlight. First, application portability between cloud environments, or even between on-premises environments and cloud environments. And second, the automation that's enabled by a container orchestration framework such as Kubernetes. Adjacent cloud native development technologies include serverless technologies, functions as a service, APIs, service mesh, Kafka, as well as observability tooling such as Prometheus and Grafana that specialize in monitoring distributed infrastructures. So why is cloud native development important? Cloud native development is important and notable because it brings the auto scaling, high availability, and elasticity of cloud computing to infrastructures for application development and deployment. And the key takeaway here is that cloud native development brings the automation of the cloud to the operational management of application infrastructures. Developers can spend more time on coding and application design as opposed to provisioning and managing infrastructure. Another key attribute of cloud native development is its optimization for distributed computing. This means that cloud native applications and solutions are uniquely positioned to take advantage of the benefits of cloud-based products and solutions. So having made these remarks about what cloud native development is, let's turn to the topic of cloud native adoption and what it enables. What does cloud native development enable and how widely is it adopted? Cloud native development enables a quantum leap in digitization that facilitates the creation of an ecosystem of digitized objects such as laptops, mobile devices, appliances, automobiles, and wearable devices. As you can see from the chart, specifically in the orange segments, regular usage of these technologies hovers between 25% and 28%. That having been said, piloting of these products is being done by roughly 40% of developers as shown in the purple segments, which means that roughly 2/3 of full-time developers are either regularly using or actively piloting cloud native technologies. As such, IDC expects rapid increases in the adoption of cloud native development technologies as developers transition from piloting to regularly using these products. Over the next 3 to 4 years, IDC predicts that roughly 40% of new applications produced by a programming language will be cloud native by 2023, that 80% of all applications will be deployed on containers by 2024, and that daily deployments to production will increase from 7% in 2021 to 65% by 2025. So in the context of this data about increases in daily deployments to production, let's examine some data about DevOps and its influence on development. This slide shows that DevOps makes development go faster. There are two boxes worth noting in the slide. A box on the top with deployment cadences from multiple times a day, daily, weekly, and every 2 to 3 weeks. And the box at the bottom that illustrates deployment cadences spanning monthly to once a year. The box on the top shows that after DevOps adoption, as illustrated by the segments in purple, the share of rapid deployment cadences increase. So for example, the share of daily deployments increased from 3% prior to DevOps adoption to 7% after DevOps adoption. And conversely, monthly deployments decreased from 22% to 18%. The bottom line here is that DevOps makes development faster and it facilitates the transition to the cloud. And conversely, the cloud makes it easier to adopt DevOps simply because it's easier to manage DevOps processes from the cloud.
This is great information, Arnold. Thanks for sharing. Could you also comment on some customers who might be doing this type of thing and how they're benefiting?
Sure. The first example that comes to mind, Bob, is Trulia, the online real estate company that empowers home buyers to search for real estate properties. It's a company that most of us know. And what Trulia discovered was that because of the monolithic architecture of their legacy application, developers could only work on one component of the application at a time. And this meant that developers were working sequentially as opposed to in parallel and were subsequently experiencing reduced developer velocity. After re-architecting their monolithic application into a microservices architecture, however, Trulia discovered that developers were able to work in parallel on discrete components of application functionality. This meant an increase in developer velocity that translated into improvements in customer satisfaction because they were suddenly able to enjoy application enhancements more frequently. Meanwhile, the Israeli startup AgroScout addresses problems related to farming and the application of pesticides by giving farmers technologies to reduce the application of pesticides via drones and machine learning-based analytics. Farmers use AgroScout's autonomous scouting technology to identify pests and diseases sooner and apply them only where and when they're needed. Using Oracle's cloud infrastructure, AgroScout was able to update applications in minutes as opposed to more than 24 hours. So once again, AgroScout experienced a marked increase in developer velocity in ways that are analogous to the example of Trulia.
Great examples, Arnold. Thanks for sharing.
Thank you, Bob. What's the relationship between cloud native development and innovation? Well, let's turn to some benefits of cloud native development first. Benefits include high velocity development because of increased automation in the development process, hyperscale development because of the computational and storage infrastructure to perform large-scale analytic operations at scale, portability, which is something that we've discussed already, automation, which relates very closely to DevOps and the implementation of automated releases and deployments and continuous integration and continuous deployment technologies, automated testing, automated security analysis of code, and the automated identification and remediation of security threats and vulnerabilities. And finally, intelligence, the increased integration of intelligence into the development process. So what does this enable? It enables multiplied innovation by means of the ability to leverage a multitude of tools and technologies in parallel. And this multiplied innovation is important not only for net new application development, but also for application modernization and transformation. And specifically, the relevance for application modernization and transformation involves empowering developers to bring enhanced innovation to the refactoring and replatforming of on-premises applications that have been migrated to the cloud. So with that, let's turn to some considerations for choosing a cloud vendor for cloud native development. There are 5 important considerations, and they're listed here. The first of which is the availability of a rich assemblage of deployment options that include bare metal, VMs, and containers. And secondly, a fully managed orchestration platform that empowers developers to focus on application development and design, as opposed to the management of Kubernetes. Thirdly, support for APIs and API management technology that empowers developers to create microservices and connect them to one another. Fourth, database technology that supports microservices architectures and decentralized data management. Additionally, database technology needs to support structured and unstructured data, and ideally is self-managing to some degree. So once again, developers are empowered to focus on the writing of code as opposed to operational products and services. So that brings me to the end of my presentation, and I wanted to thank you.
No, thank you, Arnold. We appreciate you spending some time with us. We appreciate your insight, your research. Before we let you go, I have one last question for you. So, if I'm considering cloud native as an option moving forward, what might be a key consideration that I might be missing?
That's a great question, Bob. And I think the key consideration, or one of the key considerations that customers need to think about, is the impact of cloud native development on the internal culture within enterprise IT and development specifically. So cloud native development is not solely about the acquisition of competencies and skills in microservices, containers, container orchestration frameworks, and DevOps. It's also about a cataclysmic increase in, or very profound increase in developer velocity and developer agility. So developers all of a sudden become empowered to make decisions and have responsibilities on a scale that they really may not have had before. So the shift in the cultural transition and transformation faced by developers is significant, and it's fundamentally defined by an increase in developer velocity and developer agility.
Oh, excellent insight, Arnold. And so what that tells me is, part of this is technology, but part of this is looking internally at how a company operates and what their processes are, and roles and responsibilities as much as the tech itself.
Exactly, Bob. Exactly. So those processes need to be modified and transformed and adjusted and optimized for cloud native development as the company transitions its overall development processes toward cloud native processes.
Excellent. Well, thank you again for joining us, Arnold. Appreciate you being on the webcast today. Let's go ahead and turn our attention to a great example of what Arnold mentioned in one of his last slides, which is this concept of app modernization and sort of transformation. And we're delighted to have with us, as we introduced earlier, Matt Goldensohn, from head of architecture from Gadget Software. Matt, welcome. Could you tell us a little bit about Gadget Software and the solutions you offer?
Oh, sure. Thank you for having me. So, Gadget Software is a platform that basically takes documents and virtualizes them. So we start in the form of PDF files and transform them into mobile apps. The applications are really targeted for small screen format devices such as phones and tablets. And the information can be embedded in browsers or applications in the form of web clients or through the use of APIs. When we started out with the platform, there were 3 requirements which were really important to us across the entire platform, things that we had to consider. First and foremost, security at all levels just had to be above and beyond. When you mentioned that you were developing the application or deploying it in the cloud, people just have expectations that where your security had to exceed, or they believed your security had to exceed what you had in place were you running in a private or in your own data center. The other 2 elements were resilience and performance. So with respect to resilience, you really have to focus on availability. Obviously, you cluster so you have no single point of failure, and then each service or element or component of that platform has to scale as well. And this is critical because that scale has to be in many sort of directions at once. You may have an unknown number of customers or applications or documents all building and queuing. Most importantly, you have to handle that scale. And last but not least, all of these interdependent services really have to operate at peak performance. Latencies show up pretty quickly in most of your applications. So ADX can be divided into sort of 3 categories of applications and services. The first set of applications and services are those that analyze and upload and transform documents into the core of the product. The core itself is used to virtualize and manage and organize that information. Then the consumers are used to display or manage the pieces. Consumers also can be reports that are generated based on information that's gathered in the core.
This is great, Matt. So I understand that these applications that you've built are cloud native. You built them in the cloud. Can you tell us, kind of how they were built and how they work?
Sure. So let's focus on those three pieces or the three categories of services. The first category, again, being the documents category, is really the entry point to the platform itself. This is the point at which a user can upload documents into the what we refer to as the atomization content engine. That engine is responsible for doing analysis on a particular document, breaking it into component pieces, gathering and assigning metadata about those component pieces or topics, and then organizing that information so that it can be loaded into the core. There's some interesting side effects of all of the, or not side effects, but the other things that you get out of this is that you can take those documents, once they've been broken down, they are really collections or pools of information that you could additionally just run analytics on or, again, display. So some quick notes about this layer. The orchestration components here are built around the Circus control plane. This engine, the ACE production engine, is primarily written using Python scripts. We rely heavily on data and the data science collections of tools that are available in Python environments, and then string them together and to address the issues that we need to resolve, specifically around how do I identify images, how do I extract them from a document, how do I manage a table of contents, can I use the entry in that to organize the information, and how do I keep track of that? Also exposed in this layer is sort of the organizational rules that are used when, so a customer, for example, only sees their documents and the right people are notified and along the way of the progress of those documents. So that's essentially the analysis and transformation component of the platform. Next, we have the core itself, again, where we're virtualizing and managing the data, and we consume the output of the documentation section. Now, you'll notice here that we break it down into several types of orchestration. We use Kubernetes to manage our microservices. We also rely on auto-scaling groups for those where the granularity, shall we say, is not quite so specific for those processes. And the containers that we leverage are all managed in repositories, which are all local to this particular environment. The key thing here is that from an infrastructure perspective, you want to ensure that the developers and the engineering teams that are using this platform have the greatest flexibility with respect to this current design and future things that they may want to roll into it. You never know what the business requirements may be in 9 months or a year from now, and you want to ensure that you have an infrastructure that will allow you to quickly stand up new services, new products. So you'll notice the segregation, for example, of the data tier and microservices and application tier into private subnets. That's how we guarantee some isolation. And we also rely on external services. And again, all of these are grouped into subnets and organizations that we can make sure are properly managed from a security perspective as well. So management tier is the one public-facing piece that looks out and gives you visibility back into the private subnets. The dynamic QR code service is really here to give you a representative picture. It's looks stripped down, and it is actually, because it is just one of the component elements of the consumer suite of applications. So this particular service is responsible for if a customer points a camera at a QR code that's printed on some manufacturer's product, then we want to direct that customer directly to the appropriate documentation, information, use, whatever, for that particular product. So it's stripped down. We have, I've called out the availability domains in this particular drawing so you can see how we address resilience. Load balancers are the only thing that are exposed in the public subnets, and bastion hosts, or in the case of MySQL access, you can get to MySQL Workbench through it that way. The Kubernetes or application load are all managed by the Oracle Kubernetes engine. So control plane scales, we know that. We stand things up as we need and deploy in that control plane. And then the data tier is really segregated. So for example, if we need cache to improve access speeds and access times, or the persistence layer is all provided with Oracle's MySQL as a service. So the key thing here is this particular service was designed to scale in two directions. And the first direction being the management piece of it, allowing a manufacturer to always make sure that the QR code points at the right documentation. And then obviously the number of users potentially out there in the world that may be scanning simultaneously for codes or codes looking for documentation.
It's great stuff, Matt. It's fascinating what you guys have done, cloud natively there. Before we move on to lessons learned, I wanted to ask you just a comment on what were the business and technical reasons you decided to go with a cloud first, cloud native implementation?
So one of the primary reasons that most startups look at cloud or virtualized development platforms is trying to contain CapEx costs. And the original theory behind this is that your CapEx costs all become OpEx costs when you are working in a virtualized environment. But while that was a component of it, the other thing that we found was that probably the most important reason is speed. And by that, I mean, you can both stand up a development environment and then secure and build a QA and production environment at speeds that were just not possible with a private data center, meaning I didn't have to worry about ordering gear. I didn't have to power it up. I don't have to order cooling for it. I don't have to order networking for it. You are literally commoditizing a lot of the core pieces that you need. So for example, I can specify the operating system. I can say how much memory I need on that particular instance and how much storage goes along with it. And they're literally parameters. And were I, say, for example, want to change a chipset, it all becomes easily and available quickly to it. So I think those were really compelling reasons for us when we looked at cloud versus, build our own. Last but not least, it really is important to remember that speed thing, that when you use languages to build and rebuild environments with the speed that you can in the cloud, it's really hard to justify the private data center.
Yeah, that all makes great sense. So it looks like you've got a great thing going there. Why don't we move to what lessons did you learn from all of this that the folks in the audience would benefit from hearing?
Sure. So if you look at in my experience with this product and these suites of services, security obviously is just always first and foremost. You got to ensure that you aren't doing the obvious. And it's a little problematic because that you're never quite sure what to expect. And you have to be prepared for that from a security perspective. So SSL, all of the basic stuff, make sure you cover those and make sure that data is encrypted from start through, writing it or storing it in your persistence layer. But security, security, and more security. The other piece of this, which was really important to us, was using tools such as Terraform, Helm, Ansible, Chef, Puppet, all allow us to build and configure our services in such a way that they're entirely repeatable. So those things that we have to do later on, because nothing is really static. So if you have to apply an operating system patch, for example, to a production server or service, it becomes a real predictable suite of behaviors or steps that you have to take. Critical. And again, the speed with which you can do that once you've developed a good series of habits is just really works well. And when you're trying to put a flexible environment together for all of the engineering communities that sort of live in your world, this is, again, good habits. The other thing is scaling up and scaling down. So, I mean, a lot of people look at clouds and say, well, I don't ever anticipate that we'll run out of resources. I've, done the analysis and I think we're pretty good, and you never know. Especially when you're pointing out in the world, you have an unknown suite of users, and who knows the rates at which they'll try and access things concurrently, or you have to be prepared for that. So scale up, obviously, is critical. Equally as important is once you've handled that burst from a scale perspective, you want to be able to ensure that you can turn your environment back down so that you aren't carrying the costs that you needed to scale up when you don't need to. And that's a big thing. Also, observe, record everything, logs, every bit of information that you can query about your running platform will provide you insight that will no doubt wind up being meaningful to you in ways that you might not necessarily have considered. So for example, when we see, if we're looking at application or service logs and we see a Java error that's thrown repetitively, we know we can then go back to that engineering team and say, you might want to revisit this particular piece of something. The other thing that we found is that information is often very valuable to customers in ways that you hadn't initially thought of. So an example of that is that when someone scans a QR code, one of the things that you get through that service is time and location that scan was made. So if you're a manufacturer, for example, and you've got a product and you've printed a QR code on it, and you can now start to collect information as to where those codes were actually scanned. Where is a user or a customer looking at your documentation, and how long do they look at it? That's valuable. And so we found that, just again, gathering that information and reporting it back to the manufacturers was very helpful to them in the long run. And last but not least is test and retest. Test your environments, figure out ways as code transitions from development into QA, from QA into production. Those test cycles are critical to identifying any issue. And obviously you don't want your customers to find issues. You would rather you find them either at the development or QA layer. And again, based on the amount of data that we gather, the kind of information, the kind of recording we do, and combine that with testing, we get a good idea of how well our infrastructure is actually working and what we may need to change or tune in the future. So it's nice for a closed circuit. You think of it like that.
Matt, thank you so much. Those are great observations and lessons learned. I think everybody on this webcast can benefit from what you've been through and what you're actually currently going through. Appreciate your time and attention in putting all this information together for us.
Yeah, it's been a pleasure.
All right, so let's conclude this webcast with a couple of notes. If we go to the end here, we'll share just a little bit of information about Oracle and Cloud Native. You've heard of, from IDC about adoption, definition of Cloud Native, what to think about when picking a cloud vendor. Here's information about Oracle and our support for Cloud Native, everything from helping you build out to running and managing Cloud Native environments. There are some links on the right-hand side of this this slide to information around Cloud Native, DevOps, and then some really useful blogs that Matt actually shared with us that he found were instrumental and helpful in their journey. As you can see at the bottom of this slide, support for all kinds of utilities and tools and approaches to development and Cloud Native implementations are all supported on Oracle's cloud infrastructure. All right, with that, let's wrap up our webcast today. We thank you for being with us, and we once again extend a special thank you to Arnold and Matt for your time and your preparation. We appreciate you being on our webcast, and we wish you all a great day.